Hey guys, today's video is about model evaluation. We've finished the introduction to ROC curve in the last couple of videos, but I want to introduce AUC in this video. Don't worry, AUC is relatively simple if you understand the concept of ROC curve. To recap, ROC curve is used to select a beta cutoff from multiple candidate models. When I say multiple candidate models, I mean the models with different parameters, but the algorithm should be the same. In specific, each dot on the curve corresponds to a certain cutoff. For example, we may classify patients with test results larger than a certain number as infected. The purpose of ROC curve is to help us find out less certain number, which leads to the classification results we prefer. However, what if we want to compare the classifiers, not just the cutoffs? Yes, we use AUC, which stands for area under the curve. So, what are the classifiers? They are algorithms that automatically classify data into different classes, such as decision tree, logistic regression, and naive Bayes. Now, let's jump back into the ROC curve. The ROC curve for random guess is the diagonal line. It's because you have 50-50 chance to get the classification result right or wrong. Then, intuitively, AUC for random guess is 0.5. Wait, what just happened? Don't worry, I'll explain now. The range of TPR and FPR are both 0 to 1. To illustrate, for TPR, the worst case you can have is to incorrectly classify all the positive data, then you get a TPR 0. On the other hand, the best case is you correctly classify every single positive data, then TPR will be 1. Therefore, TPR can only ranges from 0 to 1, so does FPR. Following this, the maximum AUC possible is 1, which is just the area of this square, 1 times 1. As a matter of fact, we want the AUC to be as large as possible. Imagine the ROC curve with AUC equals to 1. This situation only happens when the TPR always equals to 1. That is, the model always correctly classifies all the positive data, regardless of the cutoff or the false positive rate. Most of the times, getting all the positive data correctly classified is our goal, so this could be the classifier we are pursuing. Therefore, a general standard is to select the classifier with higher AUC. One thing to note is that AUC is not perfect. It's just a summary of the performance of a classifier. It's also convenient because it incorporates different performance measures into a single number. However, it's not so accurate because we are comparing the classifier as a whole without considering the parameters. In conclusion, we use AUC to compare the performance of classifiers because it's convenient and it mostly works fine, and we want AUC to be as large as possible. Nevertheless, we don't consider a classifier with AUC less than 0.5 because that means this classifier works even worse than the random guess. Moreover, using AUC to compare classifiers is not rigorous. It's just a generalization of classifiers' performance. So, it's fine to use AUC, but don't solely rely on it. Alright, that's all for today. Thank you for watching my video and see you soon.